Okay, so wildfire as a process again is going to have three main phases in the wildfire kind of life. So the first phase is going to be the pre-ignition phase. So at this time, the fuel is at a very high temperature, and this temperature is gonna basically sustain it so that the water content is not very high. So it needs again a low water content and a high temperature. So in this pre-ignition phase, there are two main processes, and those are going to be the preheating and the pyrolysis, and they happen in that order. So for the preheating, there is a loss of water and other volatile chemical compounds. So that's a big word, volatile chemical compounds, or big set of words, I should say. So basically, a volatile chemical compound is a compound that is easily vaporized to gas. So things like gasoline is going to be a volatile chemical compound. So if you think of gasoline when it spills, it will evaporate very quickly, which is something that you can witness when you smell it, right? Right, those things that you're smelling are going to be the vapor compounds that vaporize. Indeed. Okay. And then, so that's going to be preheating, the loss of water and those chemical compounds. And then the second process that undergoes in that pre-ignition phase is going to be pyrolysis. So the pyrolysis is a group of processes that degrades the fuel as heat is dividing or splitting large fuel molecules into smaller molecules. So some products of pyrolysis can be things like volatile gas, mineral ash, tar, carbonaceous char. An example of when you may have caused yourself pyrolysis are when you burn your toast in a toaster and you see that kind of black char that is on top of your toast. And there's also smoke coming out of your toaster. All of those things are like the beginning. That's the pyrolysis process. So you see there in this image, that's sort of what's undergoing in the second part. And this up here would be the preheating process. You can also see this pyrolysis effect going on when you are ironing your shirt, for example, and you will leave the hot iron on top of your shirt and it starts burning, kind of. That is the same process of pyrolysis. That's what's going on there. So the second phase of a wildfire is combustion. So again, first one, pre-ignition, second one, combustion. So combustion will begin with ignition, which makes sense. So if you think about an area, any area in the world basically, in a period of 50 to 100 years, every acre of the land will be struck by lightning. Okay, so every single acre in the whole world will be struck by lightning in a 50 to 100 year period. Excuse me. And basically, this lightning will cause a fire. Whether it be big or small depends on all the other factors that there are to know. So, in truth, when humans ignite wildfires, is not necessarily a relevant thing because it's basically just speeding up the process, if you would. So, it could have happened like if a person ignites a fire and the area is already bound to have a fire once the lightning strike hit, then it's really not a huge deal, if you know what I mean. Because it would have happened as soon as the lightning strike occurred. If there's enough fuel, enough oxygen, enough heat, it would have happened. Okay? So, let me see. So again, wildfire will need fuel. So if a wildfire crossed through an area 5 years ago, for example, it is unlikely that even by human ignition, another wildfire would actually burn that area because there's not enough fuel. There's not enough mature fuel, not enough mature vegetation for the fire to burn. So if, let's say, whatever has burned recently, if you guys have been to Featherville and Pine, that area burned not too long ago, I think probably like 2 or 3 years ago. If a person were to go there, a camper or a hunter or something, and ignite a fire, it would actually probably not it wouldn't go very far because there's not enough fuel in the area for the fire to go because everything has been burned already. Okay? So again, fires will occur whether people ignite them or not. So in that case, humans play a relatively minor role in terms of the ignition of the fires overall, in terms of large wildfires at least, and forest fires, I mean. Okay, so this combustion is going to be a continuum of processes that start with an acceleration of the pyrolysis that we had seen, and then again, pyrolysis started in the pre-ignition phase. Ignition will occur many times during the life of a wildfire, meaning you can have a fire sort of close to be extinguished, and then due to the sparks, for example, that come out of the wildfire, those may ignite a different area close by, and so ignition can occur many, many times during the life of a wildfire. And it can occur close to the wildfire or a little bit further, say a mile away or something, depending on the conditions. And we'll go through those conditions in a little bit. So there are two main types of combustion. The first one is going to be called flaming combustion. Oh, I should also mention, give me 1 second. Oh yeah, sorry, no, I did say that. Sorry. Okay, so we have two main types of combustion. The first one is going to be the flaming combustion, which is basically rapid, high temperature conversion of fuel to thermal energy. So in this case, there's going to be large amount of residual unburned material and very large flames. And this is usually the early stages of a wildfire. So you have very large flames. This is probably the part that scares most people, but it's really not the most harmful overall. And then there's the glowing or smoldering combustion, which is usually in the later stages of the wildfire, pretty much when the wildfire has evolved a little bit. So in this stage of combustion, there are no flames, or not very many. There's only heat, a lot of heat. And so it's like when you have a wildfire, or a campfire, excuse me, and the logs are no longer burning, but you have all that charcoal underneath. It's still very hot, and if you were to place more charcoal or wood on top of it, it would also burn it because it's still hot enough and it has enough oxygen, and it has now new fuel, so it would still light up. So that's the same idea for that glowing or smoldering combustion. So again, during this glowing or smoldering combustion, the fuel itself is going to be blanketed by an ash layer. So there is pyrolysis occurring, but it is not very rapid. It is not very hot. So you might wonder why it's blanketed by an ash layer. If you are, that's a good sign. And this is because of the flaming combustion that happened beforehand. So because of the flaming combustion, it did cause some ash to go up and then fall back down into basically what would be the new fuel. So because of the ash layer, it no longer has resources to burn the fuel right away, but it does it by heat. Okay? Okay, if it didn't make sense, ask me or look in the book, but I think it's still pretty straightforward. All right, so again, during that phase of combustion, there are two main ways in which we have heating going on. So if you remember, the main three types of heating that can take place are through conduction, convection, and radiation. So remember, conduction is when things are pretty much touching each other, and that's going to be a fast way to transmit heat if you are touching the thing that's undergoing. So if you remember from a couple chapters ago, I had that image of the pot. The conduction was going on when the heat from the stove went all the way to the handle of the pot, because the pot is touching the stove and the handle is touching the pot. Okay. Convection is going to be when you have heating of a fluid. So it can be either water, air, or whatever fluid you choose it to be. And it happens in this convection cell. So those are rotating cells that basically when the hotter convection cells get hot, they will rise up because they're less dense, and then the colder convection cells will sink down because they're more dense. So that's kind of like an undergoing circular, if you would, motion in the heating system. And that's how we got storms, for example, through convection, right? So convection is for the most part responsible for atmospheric processes as we know them. And then radiation was radiant heat that you actually get from, for example, the sun. That's the type of energy that we get from the sun, is through radiation. So convection is mostly responsible for the replenishment of the oxygen to a wildfire. And what happens is that when you have the release of heat and other gases into the atmosphere during the fire, these are very hot. So again, they're going to be less dense and they're going to rise up within the atmosphere. So as they rise up, they're basically leaving an empty space, if you would, near the fire. So that empty space is getting replenished by fresh air that came from above. Again, that fresh air is colder and is more dense, and that's why it replenishes that empty space further down into the atmosphere, closer to the fire. So because that fresh air is full of oxygen, it sustains that combustion and it continues to go and take place. All right, so hopefully that makes sense. And then the third phase of a wildfire is going to be the extinction phase. So at this point is basically when combustion of either sort, flaming or the smoldering combustion, ceases. So pretty much when the fire stops, which makes sense. So we just saw the three phases of a wildfire. Now we're going to try to understand fire environment. So the behavior of a large wildfire is explained by three main factors within the environment. Those three factors are going to be the fuel type, or overall size, type, amount, the topography where the fire occurs, and also the weather. And in terms of weather, there are many things to take into account, but we'll go through each one in a little bit more detail. So let's go through fuel first. So fuel will include anything such as leaves, twigs, decaying material, grass and shrubs of various sizes, also small trees, large woody debris, and large living trees. It also includes peat in some cases. So I don't have that written down, so make sure that you pay close attention. So peat is going to be an unconsolidated accumulation of decaying organic material. So that means that it's decaying organic material such as roots, tree parts, leaves, whatever it may be. And it tends to be kind of like a clumpy kind of substance. So peat is actually considered a rock, a sedimentary rock, which I think is funny because it is fairly consolidated, but not very much so. You can still crumble it in your hand if you really want to. But peat is going to be the early stages of, coal. So if you have looked at coal kind of history, it goes peat, then lignite, then more like bituminous coal, and so on and so forth. Okay, so peat will burn in cases where fires occur in things like swamps or bogs. So those places tend to be underlain by soils that have very high organic content. So those can also be, again, types of fuel for fires. A thing to take into account about fuel is that small-sized fuel will burn faster, meaning leaves are going to burn faster than, say, a whole tree trunk, right? And you have experienced this when you make a fire in a campfire or in a wood stove, for example. When you have smaller size material, it'll burn faster and provide like a little bit more flame for the larger material to catch fire further on. Also, wooded areas are going to be slower, like I just said, and that depends on the amount of decay that there may be in the fire, or in the forest, sorry. So if I have very large amount of decay, many deceased and dead trees, then it's going to burn faster because those decayed trees have already undergone a little bit of a splitting up and making more access for the preheating stage to occur, right? Okay. Another thing to take into account is that whenever a wildfire occurs in areas full of peat, it will burn very slowly because that's just based on the nature of peat itself. And this can last very many months. So in areas that are basically swampy and boggy, that may not have as much moisture at the time, these fires can undergo a very, very long time, like it has in Florida in a few forest fires, for example.